Hello everyone, how are you all? I hope you all are fine by grace of God. I'm also fine here. I'm here to explain to you today the graphical representation of the equations of motion. In the chapter of motion and straight line, this is quite an important topic for you to understand and practice and write in the examination. So here it is. The equations of motion, as you might have already come across while studying the chapter equations of motion, are v equal to u plus at, second one being s equal to ut plus half at square, third one is v square equal to u square plus 2as. Symbols which have been used in the equations of motion are, first one is u, the initial velocity, second one is v, the final velocity, third one is a, the constant acceleration. Point to be noted, acceleration is always constant. If and only if the acceleration is constant, then and then only these equations of motion are going to come true, are going to be applicable. And t is the time period of acceleration, that much of time for which the body has moved with constant acceleration. As soon as the acceleration has started varying, then that time will no longer be counted within this t. Is it clear? And s is the amount of displacement in time t. Now without any further ado, let's come to the verification of the equations of motion with the help of a graph. The graph we need here is a velocity time graph with constant acceleration. I have drawn already for you people. Have a look at the graph here. So this is the velocity time graph with constant acceleration. So here the body has not started from the state of rest. Rather the body has started with a certain initial velocity which is corresponding to this point A, which is u. So here the x-axis is the time axis. Along x-axis we have plotted the time, and the y-axis is the velocity axis. Along this vertical axis we have plotted the velocity. So this is the initial velocity. So this much is the initial velocity. The point A, that is at t equal to 0. The body had an initial velocity which is u. And after that, some force might have been applied on the body, as a result of which it had started to move with a constant acceleration for time t. This much is the time t. Okay, c corresponds to the point at which time t equal to t on the time axis. Okay, so corresponding to this point c, the point on the velocity axis is d, which is the final velocity. So in time t, the velocity of the body has changed from u to v. Okay. So this is the graph AB. All you can see is this. A few things I need to write about this graph are OA equal to CE equal to U. You can easily understand that this figure AOCE is nothing but a rectangle. I have drawn a line parallel to the time axis from the point A, and that line is this one, the dotted line. Okay. Another line I have drawn from the point B, which is perpendicular to the time axis. That line is BC. Okay. Because of that only C corresponds to the time t, the course of time for which the body has moved with constant acceleration, after which the velocity has changed to V. So this line, this dotted line has intersected the line perpendicular to time axis from B at E. Okay, so this figure is nothing but a rectangle. As you all know that for a rectangle the opposite sides are equal, so we can surely write this OA equal to CE equal to U, the initial velocity. Also we can write OC equal to AE equal to T, the time period of acceleration, and OD equal to CB equal to V, the final velocity. Velocity acquired by the body after time t as a result of its motion with constant acceleration. Now we need to start from CB or BC, whatever you say. CB is how much? CB equal to CE plus EB. Okay, and CB is equal to V, I'm writing, and CE is equal to initial velocity, which is U, plus EB. This EB is something we don't know. This part of the graph is EB. Now how much was CB? Was V actually. CB is equal to OD, I've written already. this much is equal to V, the final velocity, right? So how much is this EB? EB portion is nothing but CB minus CE, that is V minus EU, that is nothing but the change in velocity. How much is this change in velocity? Now an important point of the velocity time graph is that the slope of the VT graph gives us an acceleration. Please keep a note of it. Now what is slope? The slope means tangent of the inclination of the velocity time graph. Inclination means the angle at which the velocity time graph is inclined with the time axis. This is the velocity time graph, as you know already. This graph is inclined to the time axis at an angle this. The graph is actually inclined to the time axis at this angle. You can easily understand. So if this angle is theta, this angle is also theta, because both these angles are alternate angles. So now after that we need to find out tangent of this angle. Tangent of theta gives us acceleration, slope or gradient. M equal to tangent of theta means EB by AE, and this tangent of theta or slope or gradient gives us acceleration A equal to EB by how much is AE? AE was T, so EB equal to AT. So this is the value of EB which you can substitute here, as a result of which we are getting the first equation of motion proven graphically. V equal to U plus AT. Is it clear? I hope it is clear to you. So I'm repeating, from the inclination we are finding out the tangent of the inclination. Inclination means the angle which the velocity time graph is making with the time axis, or a line parallel to the time axis, because both mean the same. Actual angle of inclination is this one, theta, and this theta is actually equal to this theta, because both of them are alternate angles, as these and these are parallel, and this one is getting the transversal, isn't it? In concept of geometry of parallel lines, you can easily understand that this theta equal to theta. So tangent of theta from this triangle, which is right angled at E, you can easily understand that BE by AE is actually the perpendicular by base, and that is how tan theta is defined. So BE by AE is tan theta, and slope or gradient of the velocity time graph gives us acceleration, and that is how the inference is from the VT graph. So A equal to EB by T, because AE is nothing but the time, EB equal to AT, and putting this value of EB over here, we are getting V equal to U plus AT. First equation of motion is proved. Alright. After that, I am coming to prove the second equation of motion, S equal to ut plus half at square. But for this, we need to know another inference which you can draw from the velocity time graph, from the analysis of the velocity time graph, that is the area enclosed between the time axis and the velocity time graph gives us the value of displacement. Area enclosed between the velocity time graph and the time axis gives us the value of displacement. So this is the velocity time graph. B corresponds to the velocity after time t, A corresponds to the initial velocity, C corresponds to the course of time for which the body has moved with a constant acceleration. So the area enclosed in between the velocity time graph and the time axis is this much, okay. This area can be divided into two parts. First one is the rectangle. First one is this rectangle, and the second one is the triangle. Second one is the triangle. The entire area under the velocity time graph is divided into two parts. First one is a rectangle, second one is the triangle. So we can write the displacement in time t, which is S, equal to First part is area of the rectangle AOCE. AOCE plus area of the triangle AEB. AEB. How much is the area of the rectangle AOCE? The formula for the area of a rectangle is length multiplied by the breadth. What is the length? Length is OC, the bigger side. The breadth is CE or AO, whatever you feel like to write. I'm writing here OC multiplied by OA plus the area of triangle AEB. This triangle is clearly a triangle which is right angled at E. For a triangle which is right angle, we can just apply the formula half base into height. Half, what is the base AE and what is the height BE. After that, substitute their corresponding values. OC is how much? The time t. How much is this? OA is the initial velocity, is u. How much is AE? AE is nothing but the time t. And how much is BE? BE is nothing but AT, which we have found out already in time of proving the previous equation of motion. BE equal to AT. So now you can clearly see that we have ended up arriving at the second equation of motion, is equal to ut plus half at square. After this, the proof of the third equation of motion with the help of the velocity time graph. So in proving the third equation of motion with the help of this VT graph, we have to consider the entire area at a time. Instead of dividing the area into two parts, is considering the entire area at a time, or both the areas together. That is the area of the trapezium. Isn't it a trapezium? AOCB is clearly a trapezium. So displacement in time t, that is S, equal to area of trapezium. What is the trapezium? AOCB. AOCB. So now can you remember the formula for the area of a trapezium? The formula for the area of a trapezium was half multiplied by sum of parallel sides multiplied by height. So half into sum of parallel sides AO and BC. I am writing OA plus CB into height. Height basically means the perpendicular distance between the parallel sides. So these are the parallel sides of the trapezium, AO and BC. AO and BC are the parallel sides. The gap or the distance, perpendicular distance between these parallel sides is OC. OC. Now substitute the values. S equal to OA plus CB. OA, how much the initial velocity, very clear. CB, how much the final velocity V, very clear, because CB was equal to OD, in final velocity V. And how much is this OC? OC is basically the time. So here we have to apply a trick. Time we are writing for the time being. So now see, we know that v equal to u plus at. Okay, that is what the first equation of motion is. From here we can write v minus u equal to at. Now value of t in terms of v, u and a, v minus u by a equal to t. Value of t has to be substituted over here. Is it clear? b plus u into v minus u, a plus b into a minus b. The formula is a square minus b square. So v square minus u square by 2a. Do cross multiplication to arrive at the result. 2as equal to v square minus u square. Do a side change. V square equal to u square plus 2as. So finally we have ended up arriving at the third equation of motion, v square equal to u square plus 2as. So that's it. That's all I had tried to explain to you. I hope you could follow all I have tried to explain very clearly. In case you still have something unclear to you, feel free to let me know in the comment sections. Also let me know the topics on which you want me to make videos. And if you find the video helpful, don't forget to share it with your friends who may also need to understand the things very clearly. That's all. Stay well, take care, and bye bye.